Okay, so we're taking a look at chapter 22, section 1 on the scientific revolution here. The scientific revolution roots of modern science. So when we look behind this, we've talked a little bit about the Renaissance period. We've talked about the Reformation. Between 1300 and 1600, we had a huge time in which there was growth within all areas in our world. And so we are using that and looking at that as a change. The Renaissance, or this rebirth of learning, so to speak, really inspires a lot of different curiosities in many different fields. And so scholars start to question ideas that had been in place for years and years, and is now going to look at finding new ways and new ideas behind it. The religious movement was another thing. So while the Reformation's taking place during this time period, with we know the rules and laws that were taking place there, we are also seeing the change in another type of ideal that is really the physical world that we're going to look at. So the roots of modern science themselves, we're looking at this before 1500, basically going off the knowledge that came from either the Bible, okay, or Greek and Roman sources. Those are really the only sources that we had based off of these things. We didn't really have any other type of ideals. But the medieval view goes to support the geocentric theory, where the moon, the sun, and all the planets will revolve around the earth. And there's several reasons as to why that way of thinking might be something that we look at. Number one, it's very easy to explain from a very small ideal. But when we look at it, we see that the moon and the sun are always going to rise in the morning and set in the evening, and then the moon rises in the evening and sets in the morning. That was a common thing, so it seemed very easy to understand that, well, the earth must be at the center of the earth if that was to happen. Okay. Also, the church really had this idea behind this. They had taught that God had placed the earth at the center of the universe, and thus it's a special place in which all these ideas and life unfold. Also, we see the support from the Greek astronomer Ptolemy, which, as I said, the Greeks were a big source of knowledge throughout this time, who really expands on that theory that came from Aristotle. So the geocentric theory can also be summed up as the Ptolemy theory as well. Beginning in the mid 1500s, there are scholars out there with published works that are challenging the ideas of all the ancient thinkers and the church itself. Those scholars are going to replace the old assumptions with kind of these new theories that they wanted to exist. And some of those things will consist of new ways to look at the world. As those scholars kind of replace the ideals of different groups of people, okay, we start to see something known as the scientific revolution come to power, which is really a major change in European thought starting around 1500s, the mid 1500s. And it's where the study of the natural world, based off of careful observation and questioning of the accepted beliefs, was brought into play. Um, because of this, there are a combination of discoveries that lead to that. During the Renaissance, European explorers traveled to places like Africa, Asia, the Americas. All those lands are going to be inhabited with people and animals that are previously unknown to Europe. And that opens up the door for the possibility of new truths to be found. The invention of the printing press will also help this thing out as well. It helps spread new ideas, spread ideas both new and old, to more people in the world, especially those who are the European thinkers. We also are going to see exploration fueling a great deal of scientific research in things such as astronomy and mathematics. Why? Because you would use those things to navigate. So The better instruments that you have for geographic measurements would also lead to opening up the sea. So scientists start to begin to look a little more closely around the world that they see. And they made observations that don't match the ancient beliefs that we had previously known. Um, they found they'd reached the limit of the classical world's knowledge, yet still needed to know more with this. During this time, we get a revolutionary model of kind of the universe. And so we start with this idea behind the heliocentric theory. Although backed with the authority of the church and the common sense of people, the geocentric theory does not accurately explain the movements of the sun. Okay? That problem is going to trouble Nicholas Copernicus, who was a Polish cleric and astronomer at the time. And in the early 1500s, Copernicus became very interested in an old Greek idea that the sun stood at the center of the universe. So after he goes out and studies the planetary movements that exists for more than 25 years, he reasoned that indeed the stars, the Earth, and all the other planets really revolve around the sun itself. Copernicus creates what is known as the heliocentric or sun-centered theory. We also see it called the Copernican theory at times. And it is that idea. The planets revolve around the sun. That includes the Earth. He knows for a fact that most people, scholars and clergy, would reject that idea of that being thing. So fearing ridicule or persecution, he actually decides to hold on to all of his thoughts. Copernicus publishes his findings in 1543, and this is during the last year of his life. And he receives a copy of his book on the revelations of heavenly bodies that he gets on his deathbed. So while revolutionary, Copernicus's book causes a very big stir at first. So over the next century and a half, other scientists built on the foundations that he laid. Tycho Brahe, who was a Danish astronomer, records the movements of other planets for many years, and he produced mountains of accurate data that would be used in his observations. But it was left to kind of the mathematical portion of things to prove. When Brahe dies in 1601, his assistant named Johann Kepler, who was a mathematician, continues that work, and he studies Brahe's data, and he concludes that, certain mathematical laws govern the planetary motions. All right. One of those laws shows that the planets revolve around the sun in elliptical orbits, not circular. All right. As was previously thought. So Kepler's laws actually show that Copernicus's basic ideas are true, and they prove it mathematically. Bring in now Galileo. He's an Italian scientist who makes very big advances within the theory of within the study of astronomy. He was a Dutch he learned from a Dutch lens maker how to build an instrument that could enlarge objects far off. So Galileo builds his own telescope, and he uses it to study the heavens in 1609. In 1610, he publishes a very small book known as Starry Messenger, and describes the observations that he had. And from there, he announces that Jupiter had 4 moons, the sun had dark spots, and it wasn't perfect, and notes that the Earth's moon had a very rough and uneven surface. That shattered Aristotle's idea that the moon and the stars are made of this pure organic substance and everything was perfect and so on and so forth. Well, Galileo's observations made that irrelevant. He also had laws of motions that clearly support the theory of Copernicus. So Galileo has some conflict with the church itself. Here we see the movements, okay? Here on the left is the geocentric theory, and the right is the sun-centered theory. And you can see how these things change the observations of one another and where each one of them is. All right. And so that's how we can understand those aspects of things. So Galileo's findings frighten both the Catholic and Protestant leaders because they go against the church's teachings and their authority as teachers. If people truly believe that the church could be wrong about this, they could question all other church teachings as well. So in 1616, the Catholic Church warns Galileo not to defend the ideas of Copernicus. Galileo remains publicly silent. He does continue his studies, though, and in 1632, he publishes something known as the Dialogue Concerning the Two Chief World Systems. The book is going to actually present two ideas, both Copernicus's idea and Ptolemy's theory, but it clearly shows within his book that Galileo supports the Copernican theory. And so the Pope angrily summons Galileo to Rome to stand trial before the Inquisition. Galileo stands there in the court in 1633 and under the threat of torture kneels before the cardinals and reads aloud a signed confession recanting his confessions there. Here is part of his recantment. With sincere heart and unpretended faith, I abjure, curse, and detest the aforesaid errors and heresies of Copernicus, and also every other error, contrary to the Catholic Church. And I swear that in the future I will never again say or assert anything that might cause a similar suspicion towards me. Those are Galileo's words recanting his ideals. He is never truly a free man after this. He lives under house arrest. Lives under house arrest until he dies in 1642 in Florence. But his books and ideas spread all throughout Europe. And as was said in that video that I showed you guys today, in 1992, the Catholic Church actually officially acknowledges that Galileo had been right. So it takes years and years. Not until 1992 does Pope John Paul actually agree to those terms there. The scientific method itself. How does it work? Okay. The scientific method is a logical procedure for actually gathering information about the natural world. Excuse me. And there's a series of steps that go with that. So it usually starts with a problem. There is some semblance of a problem or a question that arises from some sort of observation. Once that takes place, then you next form a hypothesis or an unproved assumption. So you have this idea about what this could be. Okay? The hypothesis is then tested in an experiment or on the basis of data. And then in the final step, what happens is that scientists analyze and interpret their data to reach a new conclusion. That conclusion would either confirm or disprove the hypothesis that they had. So you can see how this all works out in itself. The scientific method does not happen overnight. It takes time. The work of two important thinkers, Francis Bacon and René Descartes, helped to advance the new approach. Bacon is an English statesman and writer. He had very passionate interest in science. He believed that by better understanding the world, scientists would generate practical knowledge and would improve people's lives. And so Bacon actually attacks the medieval scholars for relying too heavily on the conclusions of people like Aristotle and other ancient thinkers instead of going out and doing the work themselves. Instead, he urges the reasoning and abstract theories for scientists to use to draw conclusions and experiment. That is known as empiricism or the experimental method. In France, René Descartes is going to develop analytical geometry, which will link algebra and geometry together and provide this important new tool for those ideals. So like Bacon, Descartes believed that scientists needed to reject the old assumptions that they had prior to this. As a mathematician, though, he approached gaining knowledge differently than Bacon did. So rather than using experimentation, Descartes relies on the mathematical portion and logic within that. He believed Everything should be doubted until proved by reason. So from that starting point, or the idea of I think, therefore I am, he follows a train of strict reasoning to arrive at the basic truths. Um, and so we see that modern sciences are really based off of the ideas of Bacon and Descartes. Isaac Newton, he's an English scientist. He's going to come out and help to bring about the theory of the single theory of motion. Okay, develops that theory and states the same forces rule motion of planets, matter, and in space and Earth itself. All right. So Newton studies the mathematics and physics at Cambridge University, and he's 26 years old, and he knows certain that all physical objects are affected equally by the same force. His great discovery was that the same force ruled motion of the planets and all matter on Earth. And so he links all that together. According to the law, every object in the universe attracts every other object. The degree of attraction depends on the mass of the objects and the distance that happens between them. Okay. So in 1687, Newton publishes his ideas in a work called The Mathematical Principles of Natural Philosophy. One of the most important scientific books that was ever written. And he describes the universe like a clock. All parts work together perfectly in ways that can be expressed mathematically. Newton was a believer in God, and he believed that God was the creator of this orderly universe. So he refers to him sometimes as a clock maker who had set everything in motion. Looking at the scientific revolution that spreads, you have astronomers that are the first ones to come about this portion of things, but other scientists start to study the secrets of nature on Earth as well. Scientific instruments that become popular, including the first microscope invented by the Dutch maker Zacharias Janssen in 1590. In 1670s, a Dutch drapery merchant and amateur scientist Anton van Leeuwenhoek, Leeuwenhoek, excuse me, he uses a microscope to observe bacteria swimming in tooth scrapings, and he also examines red blood cells. One of Galileo's students, Evangelista Torricelli, developed the first mercury barometer that would be used for atmospheric pressure. In 1714, the German physicist Gabriel Fahrenheit, he made the first thermometer using mercury and glass, and it shows water freezing at 32 degrees Fahrenheit. And then a Swedish astronomer, Anders Celsius, creates another scale that measures freezing at 0 degrees in 1742. Medicine in the human body becomes another portion of this. During the Middle Ages, European doctors accept the writings of an ancient Greek physician named Galen. But Galen had actually never dissected a human being. Instead, he studies the anatomy of pigs and other animals. Now, while pigs are a decent representation of the human body, it is not similar. It's not until Andreas Vesalius proved Galen's assumption wrong. He will dissect human corpses and publish his observations in his book on the structure of the human body. And it's filled with detailed drawings of human organs, bones, and muscles. Later on in the 1700s, late 1700s, there's a British physician named Edward Jenner who will produce the first vaccine, for smallpox. He uses something called inoculation, which is using live smallpox germs that had been practiced in Asia for centuries. So it's very beneficial, but it's also dangerous. Jenner discovers that inoculation with germs from cattle disease called cowpox gave you permanent protection from smallpox for humans. So you start to see that cowpox is a much milder disease, and the risk for this form of inoculation are going to be much lower. So Jenner uses cowpox to provide the world's first vaccination there, which should be something that we are somewhat interested in nowadays with vaccines becoming rather important now. Robert Boyle will pioneer the use of scientific method in chemistry. He's considered the founder of modern chemistry. In his book called The Skeptical Chemist, Boyle challenges Aristotle's idea that the physical world consisted of four elements: earth, air, fire, and water. Instead, Boyle is going to propose that the matter was up for smaller primary particles that joined together in many different ways. His law becomes known as Boyle's law. It explains how volume, temperature, and pressure of gas all affect one another. And so we see that the reason and order that spurs a lot of these breakthroughs in science soon move into other fields of life. Philosophers all throughout the Europe are going to begin rethinking long-held beliefs on the human condition. And it's going to set forth a new ideal that will give some thoughts on the political landscape itself. And we'll start to see these different ideals that take place in coming out in what is known as the Enlightenment. So that's it for today, guys. I will see you all on Thursday.